I want to dive into today is how we can actually start working with again some of this professional data that has been put out that is a step or two away from the actual measurement itself. And part of that, is because we don't have to focus so much on making some of these measurements today, because we have a lot of experts who are putting in the time, who are building off of 40, 50 years of research together. And so now we have a lot of predictions that we can use. And I think that's one of the pieces I want to start off with and mention and really kind of stress today, is whenever you see a map, you can think about it as a hypothesis of what you're looking at, of what might actually be there. And really, when you start looking across different maps, you start seeing similarities, but you also start seeing differences there. And especially when we're looking at the same location. Okay, so that piece is really kind of the nugget of what I want to go into, because what I'm going to show you today is just one data set or one example, that might inform what you're seeing, there on the ground. But it's not the only map. It's not the only prediction that has been made for that location, and that I think is just kind of one of these things that, if you have another data set that one of these speakers is using or has created, find out more about that. Lean into that piece of things. And so just recognize we're at this point in our science where we have a lot of predictions coming at us. Okay. And importantly, with that, we're going to start off and really, review that, and think about our own data collection here, right? When we use Globe Observer, we are doing that remote sensing data collection. But one of the most important pieces of science is sharing your data and making it actionable. And so that's really, this transfer from your device up to this database is one of the most important things. Because if your data doesn't end up in this database, or we don't get all the photos, or it ends up in the wrong location or in an incorrect location, it makes it much harder to do some of those other things that everybody wants to do, like compare it to other data or a map, or even be able to go back there and see how that place is changing over time. Okay. So hopefully this is something that you are getting familiar with now, which is the globe visualization system. And again, this is just a great place to start and explore your data, and it really should be one of those things in your process. So let me see a show of hands of how many people have used Globe Observer so far in their school year. All right, I see two, at least three, or four, three.
Yes.
All right, four, five. Okay, so if you haven't used it yet, I want to encourage you to, consider this. One thing is, like I mentioned, I mean, most people are really familiar with already taking photos. Remember, this is actually a science sample of the sunlight at that moment in time. Clouds, ground, moisture, brightness of what's there. And so that's a really good way to start stepping into and being a NASA scientist, is to actually go and do your own red, green, blue sample of the sunlight. And so, so I want to just highlight for everybody here. This map is really nice, and what I'm always happy about is all of the contributions coming in from Alaska over the last year, right? And again, one of the things I want to stress that's really it's actually a data technique here, and it's called zoom in. zoom in on your maps. You get a whole different story when you actually start zooming in. So this is a technique that you want to use with all of your data that you're working with, but it really works well with imagery, right? Or maps like this. Because you start seeing some of these underlying details that help us to orient ourselves or to make sure that this is in reference to something else, which again is one of these things that we're constantly doing. And so, so here, I'm just going to zoom in on our wonderful Fairbanks area up here and just, show you some of the imagery that has come in. And this is really great because one of the things that you again start seeing here is somebody's prediction of trees, what you might actually find if you go into that location. Here, they have a nice little thematic color code that might be trees. And so they're giving us a legend here that we can use to begin our hypothesis of what to expect out there. And then, importantly, we can sort of back up that hypothesis, right, by going in and looking at other people's data that is archived up here in the Globe database. So this is the epitome of researching, right? We're going and looking at data somebody else has originally searched and captured and then archived for us. So we're in that research piece of things. But this really allows us to go through and start doing some zooming in of our imagery data, right? So I'm going to pause right here, and we're going to do a little what do you see, what do you notice activity here together. So I'd like to go through and sort of do a little round robin where everybody said where somebody I'm going to start off with you, Joy, and ask you to what do you notice in this picture? And then say hand it off to somebody else, and then they can tell us what they notice in this photo.
Peter, is this my backyard?
I don't know. Is it? How would we know that?
Did you? Oh, me and Simone both think it's our backyard. It's got poplars and birch. What else do you see?
That looks more like a cabin.
Oh, I don't know. Where did Peter get this picture?
Mm.
Okay, wait,
Yeah.
back to the order. Keep going, Peter.
Yep. All right. So Joy, what do you notice, as you look in here? We heard Katie mention some different trees and she's noticing some different trees. What do you notice when you see this photo?
Well, I was just gonna say the same thing as Katie said, but I
Yeah.
also noticed some it must be well, it could be fall with the leaves down, but then it could be spring too with the snow
Yeah, what
melt
are
in
you
the
thinking?
background.
What do you think,
They
son?
look like kind of older leaves, so maybe I'm thinking it might be spring.
Oh, don't tell
Mm.
me.
I see some green moss and I don't see any buds on the
Oh,
On the
trees
shrubs or
though.
like
Yeah.
yeah.
something
Are
doing.
there any buds on there?
Oh,
Yeah. So I'm
no.
Boy, I
gonna
like
hand it off to Kelso.
boy, I like that, Joy.
Thank you, Joy. Kelso, you're up next. What do you notice here about this imagery?
Um, I see a lot of uh, I don't know what am I see a lot of dead leaves on the ground. Uh, next to a few trees. I don't know.
Yeah, exactly. So there you are. You're an ecologist. Congratulations. You can now go out into the field and take field notes. That's exactly it. And the colors, the textures that you're talking about. I mean, this perspective is exactly what we're doing from space. It's just, this the pixels when you zoom in are kind of different. And I really, I love this because Kelso, thank you for this because that hesitation of like, well, isn't there a right answer? I'm just going to say no, there isn't a right answer here. Okay? Part of what we're trying to practice is that whole thing of noticing, observing patterns, and then what questions might come out of that. And so, so Kelso, thank you for jumping on the hot seat there, and saying that because being uncomfortable with that question of what do you notice um, is usually a panic button for a lot of students. They think that you're looking for certain things, and you might be. You might actually zoom in a little bit on the bark, right? And one of the things that I really want to emphasize here is what happens when you zoom in. The images get blurry, right? So this is exactly what happens with our satellite data too, that it gets blurry as you zoom in. And but because we're looking straight down, each one of those pixels actually is an area on the ground. One of the things that I'll stress right here is that you don't have an equal distance as you're looking out here. And so when we're looking at our oriented images on the ground like this, unless we actually have like a tape measure or something like that is pulling our eyes out and helping us to know those distances, we can really fool ourselves with that vanishing point and that vanishing line and how far away things are. So just recognize that this has some distortion to it. And that's one of those big differences between this perspective and I'll just go back and and see, if we've done the down photo right, that down photo is almost exactly like the satellite data looking straight down. And so, so I love this because, Joy, if we go back to what you were sort of saying and Kelso, too, like, this right here is usually crisp. It should be. It should also be straight down. This is about a 1 meter by 1 meter area that we're looking at. It would be much better if we actually put down a measuring device or something like that so we could know scale, right? But one of the neat things is with something like this, if you do zoom in, you might even be able to tell the type of trees that are in that area, right? Or the vegetation that is there. So one of the things that I love is that okay, we might not see the leaves on the trees. Might not answer that question, but you might be able to still understand that because of that wonderful carbon cycle that is getting recorded here in that down photo. Okay. The other nice thing is, we do see that moss, right? That green part that is part of that soil and everything else. The other piece here that I because I've looked at these a lot, but if you zoom in up here, one of the things about snow that we expect is that it's going to be the bright things or the white things in our images. So, this is a place where if I zoom in, I might get fooled, and this could look like a leaf, or it could get mislabeled, right? But if I zoom out and sort of use my human eyes and intuition, I can actually start to maybe notice the difference between what is just bright leaf and what is actually snow in this case. This trace of snow can be one of these things that helps us to keep track of that soil moisture, actually. The darkness of this is another one of those things that we're actually recording that tells us something about that moisture in this area. So I want to really emphasize how all of these photos together are what we want to focus in on when we're describing a place. Okay, but doing them individually is really nice because one of the things that I can ask now, and I'll say this before we jump into some of the satellite data piece, is what would somebody expect if we turn to the north direction? If you're given this photo and this is of the south direction, do you think you're going to see the same thing if you turn to the north? Or is it going to be different? Let me see a show of hands of people who think that when we turn north, we're going to see a similar arrangement of trees and the photo is going to look the same. Just give me a raise of the hand since I can't see everybody's faces. But if you think it's going to be the same and as we rotate around, let's see that. Otherwise, we're going to flip around and we're going to test this out and see. So, I want to point out a couple really important things as a scientist who wants to use this photo, right? So right off the bat, I'm going to throw it down to let's see, let's go through here, and Christy, I'm going to bring you into this conversation and ask you because you're here on my screen. Is this what you thought would be in the north direction from what you had just seen? If you had just stood out there, would you think that this is what you would see in that north direction?
I'm surprised actually to see all of the smaller trees, the little seedlings. And
Yeah.
then I remember the other photo that you showed us, there was this patch of grass, but just a lot of leaves. And
Yeah,
then now you're turning and facing the other direction, and man, I'm standing in the grass. So I
exactly.
didn't expect that. And I want to see further. Like I want to see along the horizon just a little bit further to see how far this goes.
Yeah, that's really great deduction and sort of connections there, Christy, that we're talking about here. And this is one of the things that I love is that, in a class, a nice teaching strategy, since that's one of the things that we're here for, is to hand out or have each student grab a direction for the same location. And can they describe it to somebody else? Can they describe it in a way that somebody can say, "Oh yeah, I've got that photo," or I have the same landscape, and this big shift, like you were saying, in terms of like the number of trunks or the size of the trunks, that's really one of those really obvious things that makes me also say, Christy, like, wait a minute, I'm maybe on an edge of something. It's transitioning to something, and you're exactly right. This is where one of the challenges that we have with the way the Globe Observer was created is we don't know exactly where the horizon line is here. If I tried to recreate or research this image, I might actually do it a little different. I might have more of that horizon. But this is actually one of the fundamental challenges of why you need to keep track of how you do things. And then also, that initial search sometimes, gives you an indication that, oh, okay, I really need to check the quality and my and how I'm doing my data collection, right? So this is one of these things that you should do when you go and look and start looking at imagery for an area, is go through and you can quickly see how similar or how different the directions are. Right. So that right there is a really important piece of things. And obviously, here you can cheat. But one of the things I'll say is this date to me is a hypothesis as well, right? How might you know that this is October and not April, like you were sort of mentioning, Joy, right? Is there some way that you might be able to tell that difference? Okay, so I want to stress how this is part of our mystery tour that we're actually trying to do as scientists ourselves is look at spectral reflectance like this and try to understand that context. And this time of year is really one of those things that the lack of greenness is one of those things that you can use. The lack of whiteness might be one of those things that you can use as well with this. But one of the things I'll mention, and sort of highlight here that is worthwhile doing, as Christy was mentioning, you now have this ability to not just follow the protocol and take your photos in the standard north, east, south, west, up, down directions. But maybe there is that hiking path that people are actually following out there, right? Maybe there's that patch of snow. Maybe there is, in this case, maybe evidence of fire that you want to make sure is captured. That's what these feature photos are for. But again, one of the things to watch out for is when you zoom in, are you going to get the details that you want? Okay. So this image resolution is always this fun place that we can always keep improving and going back and researching this image. Right. And again, one of the things that I'm starting to look for as we switch over and start thinking really about, do you see evidence of fire in this image? Look at the bases of the trees. That's like one of the most important things. Usually, what you'll see is black, right? Most of us saw that this summer when we went out and walked around, in the fire landscape, right? Black on trunks, tree trunks are one of those key indicators of having a recent fire, or being fire adapted or having that impact there. One of the things that is sort of the opposite is green on the bottom of a tree, right? That usually indicates that even if there was maybe a fire or something, because of the height that this green is going up that tree, if there was a fire here, it didn't go up the trunk. It didn't seem to impact the tree. It might have impacted some of the grass or other things around it, but the fire flames themselves weren't going up the tree like this. And this is one of those pieces that you might see 5, 10 years after a fire as well. So these feature photos and making sure that you get them detailed enough is really a most important piece. And so, to me, when I look at this area, I don't initially say, "Oh, there's been a fire here." I don't really see that evidence in this particular photo. Um, but that's to me one of these things that you can use, right? Knowing that this does not have any evidence of fire in there, that is science. That's actually our science project right there where you can start. And again, one of the things that you're trying to do is maybe narrow down the time frame of when you are seeing evidence of fire in your landscape. Okay. And I want to emphasize that this date is an important part because it's not the same where I am. It's not the same all the way across Alaska. And so, this timing is something that we can generally talk about summer. But those specific dates of when things are happening are really important. So I want everybody to remember and focus in on that. Okay, so that's to me one of these big pieces, and I'm going to zoom in a little bit more here because I want to show you again. Here's some of the data that we did this summer and collected this summer, and in contrast, right? Here's what an area that looks like that has had wildfire go through it, right? And so this, if you can remember, which is one of the challenges we have, which is why we have this database, is you notice how dark these trees are or the tree trunks are, right? So that's really one of those things that we are making a science measurement about the intensity of the sunlight at this moment and the darkness of these trees here at this point. The other thing, kind of going in, if we look at this, we do see some evidence of brown, dead vegetation and some other sort of things like that, again, with some ground measurements, might be informing us about, some environmental condition that's out there. And so, so one of the things that I do expect to change over time, right, are these piles out there. The height of the pile, the volume of the pile, the color of these. That's one of those reasons why I took this imagery right here, is because I know this landscape is going to change. So, this to me is really one of the most valuable parts of working with the Globe program is having this shared database. But I want to emphasize, taking photos of a location is something that you can do on your own in your own community, and you can control the data, and you can have all of that. But sharing it and archiving it out here, really is that big collaboration of science that we're doing, because um, you know to make it to really start seeing our trends here, that's really where we have to have all of this co-located information. Okay. And I want to stress here, I'm going to just flip over. And the nice thing is with this mapping system here, if you choose the three little dots, you can go over and choose a different base map to look at. And so with that, I always like to go down and start looking at the satellite imagery. So, the nice thing about this is, we were told, that this fire wasn't very big. And we can really see it's not. But, and here again, zooming in, using that zoom in technique, you can really start to see the areas in trees that were not affected, and areas that were affected. Also, you'll start noticing the images start getting blurry, just like what we were looking at. That is the same issue, image resolution. One of the things that I really like about all of the images that you all contributed and worked on this summer is, these up photos. Like, I can't zoom in any further because these things keep getting smaller. But one of the things I really like is I can see differences in that tree canopy just by the up photos that were taken at different places across this fire. And so, as I zoom out, the images get a little bit better, and you can really start to see, we can see the sky here. Okay. And that's one of the valuable things of whether you do a cloud observation or a globe observer land cover. This is that up photo of the satellite is really the matching piece of things that I love so much. So you can see, this is the data that we were able to collect. It looks like for some reason, we weren't able to get the full perimeter walked. For some reason, I don't know what happened, but I thought I remember us taking a whole bunch of photos over here. So this to me is one of these parts that I didn't do a good enough job as a scientist remembering how many photos I took, where I took them, and my brain is a little bit fuzzy on the data over here and what's going on there. So that happens, but this is a learning opportunity for all of us, and why you want to go up here and start looking at and examining the data that got up there. Did all of the photos you took actually end up in the database? You thought you were going to send six. Well, if you actually look at all of these going across, did all six of those end up there? I love this one as an example of fire and what happens, right? Um, and again, this could be green, and maybe the sun is just kind of blocking some of it, but maybe it's black. That's where, again, this illumination is, you can't tell always from one photo or one image what's going on there. Okay. So please, dive back in and use all of this imagery that we have, because, look at that nice collage of six images. And again, this down photo really gives us those details about fire recovery. And I'll highlight, or ask somebody, now, what do you notice about this photo?
I see good fire starter with the lichen, but then I
Yeah.
also see my favorite fireweed poking up.
Yes. Exactly. And not flowering yet either, Tori, right?
Right,
So
right.
so that's another sort of thing is you're getting a little idea of height in part because we actually have a reference of a person right here, right? So we can actually use their shoe size as a little bit of an indication of scale. Right. So that's one of those most important things that an image is useful by itself. It's even more useful when we have scale, when we have depth, when we know some of those attributes about it. One of the other things here, if we zoom in, right, one of the things you might be seeing over here is again the needles from the tree, tree branches that might be around in that area, or it might be another herbaceous plant kind of coming up. We can't really tell. And so this limitation and being okay and saying like I can only tell this much by with this data set is something that is okay. And it's actually really good to to highlight those limitations. Okay. So yes, and one of the things too here is if we zoom in between the feet, we see some green of the moss that was there, but it's more brown, right? So all of these things are kind of giving us indications again of fire, evidence of a fire in that landscape. So, so to me, spending time doing this is really valuable because not only are you going through and working through and developing your understanding of image interpretation, but you don't have to go anywhere to see satellite imagery. It's right here. And so, so that to me is a great place to start with this connection to NASA science. Okay. So always, double check your data, see that it's there. And that to me is the important piece because once you figure out your coordinates, right? We talked about that this summer. Now you can actually go and start exploring some of the other data sets that are out there. And like I said, there's a lot that are out there, and so I'm going to go over and I'm going to share with you this particular tool. And this is something that I'll make sure to answer the questions in the chat here, but I want to make sure that I get to this map because you can spend a lot of time on this map. And that's a really important thing because, again, this to me is a hypothesis. It is giving us some predictions of what we might find in a place. And, and importantly, it is a shared map. It's one that covers the continental United States and all of Alaska. And that is a really important thing for me because then we can all be on the same map. We can be talking about the same methods, the same data. Okay. And this is something that shifted. When Joy, was mentioning, the Shagalak burn site, when you guys first started doing data out there, data collection out there, it was really about making your own model for your own landscape. And so so one of the big things now is we pooled all this together, and you're not on your own. And so here there's wonderful tutorials inside of here where you can go in and learn how to use this tool. I recommend, just doing that with your students. Do it with your class. Hey, we all are learning together at the same time. Nobody really knows much more than others with this. And what I mean by that is this was only developed in the last 3 years. So and demonstrating how you learn new tools is great for students to see. Okay, so that to me is kind of one of the most important things is grab your exploration tool set and dive in. Okay, and when you end up here, one of the things that you will see is that there's layers, some information. Well, okay, that means that you have to do some reading and you have to find out a little bit more about what are these layers. You can think about this like any literature review or any background information gathering that you might need to do. But the nice thing is that you do have, some things that we've seen before. Like one here is if you just turn on the land cover, hey, that sounds familiar. We were just looking at that, right? Here you can actually see the parts of the world that this covers. And in fact, it covers Hawaii, Alaska, continental United States, and also Puerto Rico. Nowhere else. So this is very specific to our, the federal government and their focus. Okay, but it's really made to give us the ability to save some time and resources. So here I am going to try to get to Shagaluk, and yeah, apparently I'm not spelling it quite right over here, right? And so here, let me go back. The wonderful thing about Google, right, is you can hopefully find where you need to go eventually like that. But all right, sorry, Joy, I'm not quite getting it right. Um, okay, so but I'm yeah, okay, so I'm gonna zoom in over here because I do remember. It still remembers last time we were looking at this. So I really appreciate that. And so, so you'll see that there are some locations that I've already picked at or pointed at on the map. But again, this right here is the land cover at a moment in time. And the moment in time is the most recent moment that they say. And here it was 2024. So it's about a year behind. And so that again is one of these things where you can use this map, especially if you zoom in, as a hypothesis of what you might experience if you go out today and then gather those globe observer photos, and voila, you are hypothesis testing. You're checking to see whether there's actually trees growing here, like this indicates, or whether this is actually been recarved back out and is now a water channel. And I'm very suspicious because the label on the map says Inoko River right underneath where this is showing trees. So, so this is a really important thing that it's okay if the maps are wrong. The important thing is that we're going to, through Globe Observer, give scientists a way of getting some evidence of what we're saying and what we're saying is happening in this location. And so, so that's kind of the name of the game here. And what's good is you can go in and you can actually slide this transparency down and be able to see what's behind it. Unfortunately, here in Shekaluk, it's all snow. And so we're getting a winter image, right? And so a winter image may not tell us a lot about wildfires. Um, but if we actually zoom in, this is where if you zoom in far enough, in fact, you might actually see the effects of wildfire during a winter image. It might be darker, it might be black. You might see sticks of the shadow or something like that that is out there that is kind of an indicator of,
Can you
hey,
go into town there?
yeah, I definitely can, Joy. Um,
Zero, yes, zoom in on the town and okay, and then go a little bit south. So that's town, that is Shadwick
yep.
Village right there. But
Here's
if you can,
Hamilton Street.
oh yeah, oh yeah,
Not many of us have a street named after us.
right, yeah. So right, so you're going up the dump road right there now, I think. Is that the dump road, Santa? Is that your house right there, Santa? Oh, yeah.
I think
So where
so.
your little hand is right there, there's a little house out there. That's Santa's house right there. Yep.
Yeah.
Yeah.
And if you keep
Spotted.
going down that road, that south road, and oops, maybe zoom out just a
Yeah.
tad. There you go. And go back on that road,
Hmm.
and you'll see the burn site at the very right there, right there.
Yep. Yep. Exactly. So let me ask right here. Looking at this, how many hands of people would think that this is a fire affected area.
That's so funny too. You see that little square, little forest piece right there? That is our globe study site.
Right.
Exactly. That is our globe burn site. Um,
Right. I
the
never.
community had well, GCI was renting part of that lot for their tower right there. But you can see too where the fire actually extends kind of beyond
Mhm.
that little white area. That little white area was plowed up by the city of Shaglook to make a little ball field.
Yeah.
And so they let us keep that little square right there. Perfect little
You
square.
Exactly. And so, so to me, this is one of these things that I don't have any control over this imagery. I don't have any control over the date. I don't have any control over the resolution. And so, again, that's a limitation of this tool and lean into that limitation. But one of the things that this really helps me to see is one of those things that Christy was sort of like highlighting is where is the snow? Is it all on the ground? Is it in the trees? Or is it up in the sky? And when I start seeing snow in trees like this, I always start asking myself too, how long is it going to be there? And is it going to blow off? Or is it going to just fall straight down and add a snow pile there that I can't go into? But and so that's one of these things that when you're looking at a winter image like this, look at where that snow is located. It is giving us a little indication of the things underneath it, actually, and I just find that to be really fascinating. One of the other things that I want to stress here is how important these shadows are to us understanding and even keeping track of the height of trees. If we know where that sun is at on this date when this image was taken, there is a way that you can use that to calculate how tall this actual tree line is. And so there's a lot of detail that we're getting provided through this. It's not just this land cover prediction, but I really like this because if we go back up and show you what the models are predicting here, we are seeing we're missing that some of that detail that you were talking about, Joy, and especially this really clear area right in the middle that has the snow plow or snow tracks in it. You can see this is below our minimum mapping unit, or it might just be incorrect. But the fact that I see a difference now between this map and what we've been measuring, or Joy, what you guys have been measuring and putting into the Globe database, again, this is what we want to highlight to scientists and say, wait a minute, this is actually not trees. And this helps us to better understand how many trees are out there. Right now, we're overestimating. And so if we look at this and say, oh, a fire went through this area and it changed it changed trees out here, we wouldn't really know how much or in what way, right? So that's one of these reasons why we're really focusing on the land cover just by itself and trying to understand what that is like. So again, our legend is really simple. And so this should be something that even young students should be able to connect to. Trees, shrubs, grass, water, bare ground, right? So but I want to give you a little insight into why I was so excited about this. The land cover piece has been in the works for a while, but we've had that. The most important one that is new, that is giving us a brand new prediction, is actually this prediction of what type of change has occurred in that area. Okay, and so here we can actually see that there is some pixels that show up on the map. And just like anything, we have a legend over here that has way too many colors, way too many numbers, and should take you a while to decode. And that is okay. And spending this amount of time looking and trying to match up, how do you know what's happening here? What is this prediction? That's one of those challenges. Luckily, you do have some tools over here that allow you to actually click on some parts of the map and get some information back. Okay. But one of the first things that we always do as humans is we try to match up colors to these things over here. Right. And so in this case, I'm seeing that there was tree removal here. It looks like there's maybe a little bit of defoliation, is what they're calling it, or insect disease or stress, right? One of the things that you can think about is, do you have an example photo or an example of this change type in your community? Is this one of the concerns maybe that you are after, that maybe this map actually shows you where some of those changes have occurred? Okay. So I'm going to zoom out now because um, that to me, Joy, is a great example of a lot of things happening in one place over 30 years. And so, again, to me, what can you bring to the party to help us to understand what we're seeing here? And luckily, you've been putting data into the Globe database, so I can actually go over here and find your data in the Globe database and start to put together what you've recorded for that same location. Unfortunately, it'll take some time, so I can't do that right now, right? So I'm left with trying to use the map here, trying to use the imagery underneath it. But you can see that when you start doing this transparency overlay, another data technique here, you can actually see it does a pretty good job of seeing of getting this square piece that you were talking about, Joy, right? And so to me, what this leaves me to, and where I want you to leave you all with, is now it's time to go out to these pixels and make measurements. Use Globe Observer first as your rapid assessment of what's there. That's great. But if you happen to then after you've done that, you can make the choice about what now should you measure. If there's trees there, great, measure those trees. If there's soil there, which there probably should be, you can make some soil moisture measurements, and use the differences here that are mapped out for you as the places that you want to make your measurements. So I would go to a green area. I would send maybe another group to the purple area, right? I would even go to these orange areas on the edges and look at what is happening there, what is being measured there. So that to me is one of these ways that I am using this map now to guide where I go. Because you can see that one of the things that they have not done is filtered out these small 30-meter areas. This is one of those things that other maps you've looked at probably have done, and they've removed some of the details that are really interesting. So if you see one of these pixels lit up or highlighted like this, go investigate it. You might find something very surprising that is where scientists are very uncertain that things might be happening there. To end
Question
it,
there, Peter.
yeah. So
So,
yeah, Joy, what's kind of happening? Oh yeah, interesting. What's kind of happening there?
oh, I see what you're doing there. Okay,
Yep.
so if I were to stray off the beaten path there, so to speak, and I do notice like there's a trail
Yeah,
near some of those little pixels that were highlighted in there. There's a
yep.
trail right there. I don't know if that's an animal trail or Santa,
Exactly, Joy.
is that our ski trail, Santa?
It looks like it could be
Yeah, it
something
looks like a
exactly like
trail,
that.
at least one that's partially used sometimes.
Yep.
Yeah.
There's a bunch of little trails where like kids have trap lines that they use sometimes
Mhm.
too.
Yeah.
Yeah. And that whole thing of okay, yeah, follow that out. And then, and this is where the research piece comes in. how do you get to that coordinate, right? So you need to use your GPS skills, or you need to figure out how do you research a location. And again, how do you navigate back to a place? That to me is a wonderful skill to just be teaching and sharing with each other. Because one of the things I'm going to zoom out here, but you see, Joy, there's so many places that now we have a hypothesis that says, oh, well, there was wind out here, or I love this one, other loss. What is that other? Like, what could that be? The scientists have no idea, right? And so, so again, these are great hypotheses, and I want to encourage you. What in these pictures might be indicators that you're seeing a prescribed fire? Can you see that difference between that and wildfire? Is there a way that you can come up with evidence that you can use to identify these types of changes that are out there? And then, like I said, the wonderful thing is now you can zoom out, and one thing that you're seeing is every fire since I'm going to say 1986. I could be wrong, maybe 1990, but you can see in here, like, um, how close some of these have been to Shagaluk there, right? And this to me is this next piece that is all full of this exploration. Where is the closest fire that has occurred to us? When was it? How did it occur? And that's where I'm just going to point you to this tutorial is being something that is right there. There's videos, there's other things like that that you can that will give you how to read this and how to use this. But this piece right here of the land cover change, the agent of change, that right there, it to me is been one of those parts that has been hidden from our communities. And now you can really get in here. And I just love this because you can see such detailed information. And again, I want to encourage you to keep using this zoom in technique, because as you do that, right, we start to see interesting things, that with some context, you can actually see the maybe some of the other losses that have happened out there, or the vegetation successional growth that has occurred out there. So use this as a great way to start diving into your local area and just investigating these hypothesized areas of change and what could be happening out there. So I'm going to leave it right there because I could keep going on with this fun topic for a really, really long time. But that's why you're going to invite me to your class, and we can do this as a class together, and fill out some sheets like that, where we're actually comparing what people see to the labels right there. And I'll highlight that, inside of here, you have what everybody is used to, Pegman. And so if you want to just drop in to some of these places, you can get a ground photo just like what we're creating with Globe Observer for some locations. And you can see even they have the leaves on the trees there, right? And this is one of those ways that you can connect to people and maybe some of the activities that they've already been doing. But the key is for us, we're not always on a street. And so, this lack of information or data out here is one of those things that we're trying to sort of reconcile, right? So you can have a lot of fun just like dropping yourself out on the landscape and seeing what evidence and types of changes might be out there. Okay, so I see a lot of great questions coming up, and so I'm going to ask and find out. Does anybody have any question, sort of final questions here, or questions that I might have missed in the chat?
I just had one more comment here. So when that Typhoon Hailong, whatever it was called, was happening last fall, we have a lot of downed trees in our Gash area, our Grayling, Anvik, Shagluk, Holy Cross area. And in fact, it's created such a nuisance for people um, to um, to visit, to go village hopping and travel and plan events and carnival events and school events, with the other schools. And it would be interesting to see satellite data of the area of trees that have there was a giant area of trees that have fallen down because of the typhoon.
Yeah, no, you that is a really good, important part because one of the I think to me interesting things that you guys are all very aware of is how these river systems transport carbon down and through a system, and so keeping track of these log jams, the type of them, the shape of them, where they're located actually on the bank of the river is a great way that we can reconstruct the evidence of an impact of some of these locations. And so I really, Joy, I love that. It's because it feels like something that is overlooked, but yet the detail and information behind all of that can really take you back to floods that were 50 years ago or even further, right? That it moved some of these giant trees downriver. So again, when I'm looking at these images, I'm looking for some of these straight lines and some of these tanglements that help me to understand, not just that a tree fell down, but that it actually moved from this location and then it ended up downstream. And that really, reminds me a lot, Tori, of kind of what you guys were doing, mapping out, some of the movement of these pieces that get left behind in certain hazard events or after big events and things like that. All of that's really important information
Yeah,
because it gets at that uncertainty that currently is in everything that we do in science.
Thank you.
And so the more that we could get in and really tie our work to this
You.
authoritative work like this,
mm,
and help them improve what they're doing, we're going to end up with better products. And um,
the
and and
green
and the
people
and the
the
whole
green people get
excitement
the
of
glasses.
this one is that we Alaska is so big that to actually put this together at 30-meter resolution like this took 4 years. And it took 4 years longer than the continental United States. So I've been doing this work with this data down here for a while and just anticipating and waiting for this day, that we can actually be talking about the same data using the same tool like this. And so that's what I wanted to present today and give you guys something that's really cutting edge that nobody has really looked at the location that you are mapping out. So, in that way, it's authentic science in a way that might not be the same in a couple years. We'll have looked at this. But right now, nobody can really do what you all are capable of doing right now. So I really want to encourage you to dive into this, look at this, change layers, and use that to inform some of the investigations that you might want to do. And again, nobody should have the answer right now. So investigate, investigate, investigate.
That was wonderful. I love a good map, and I'm like frothing at the mouth to try playing with it there. Any questions from the group? There were, lots of good comments.
Uh,
Joy, does the aurora ever have any effect?
yes. Yes, all of that electrical energy. At first, it has to get through the satellites and pass through, and so you can get bursts of energy that actually make it hard for a satellite to make that measurement. They might have to go offline, or it might even cause some spikes in the images itself. But it all goes back to the timing of this. But as you guys know, just because the sun is up doesn't mean that the auroras and things like that aren't happening up there. It's just that angle and the way that it's getting illuminated is different. So yeah, Joy, everything is connected, and that one of the things that I'll highlight that is just wonderful that I've learned about everybody looking at auroras right now. is how much more detail you can get out of seeing an aurora with your digital camera than you can with your eyes. And that is remote sensing in action. That's taking what is out there and making it real for us. So, lean into some of those. And what I love is like the aurora photos in the winter, and then go back out in the summer and do the same place and show us, that difference. So there's so much, that is possible with this repeat photography piece or repeat imagery piece that I have a lot of science projects for the years to come. And so, James, to answer your question about updating, this is a yearly map. Okay. And that's really crucial to understand, is that it's going to be updated on a yearly basis now that we have this baseline. And so this is about 20 years of experimentation, with all of these algorithms and everything to now get them stabilized so that it's easier to bring in just what happened this summer. And then you can just put that right in line. We have this map, we have this system. And so that's another big reason why, I want you guys to start getting used to this tool, is because it is going to be updated and it is going to be changed. And it can be an authoritative use that you can share with people. And again, since it sits on Google's tools, it has a lot of these things that we're all familiar with. And I've actually taken this out with me and used this. There's a little button at the top, where you can locate yourself using your browser, and it will show you exactly that pixel. So I've actually used this when I'm standing out in a place and wanting to know, is this a good place to do my observation? Use this map to actually locate me, and I find out, oh wow, I'm standing right in the middle of Joy's past observation from the year 2005. Oh great, this will be a perfect place to do this. So this ability to take our map out with us, is something that again, start thinking about what it might be like to actually walk into this map with your students. So, again, I'll be coming back to this a lot, that's going on, but I really appreciate you guys doing your part with the data collection so that I can do my part, which is creating maps like this and data like this. And we'll just meet in your classroom together one of these days and talk all about what we have together to share.
Wonderful. Thank you, Peter. I love how you tie in Globe Observer with these new tools and how we can use them to not only guide our inquiry, but also with the current work that we're currently doing. So,
Yeah. Yeah, and I'm seeing some nice comments over on the side. So please keep sending these things to me. I actually will end my comment here, Tori, with saying, I know you might have said that a lot of times. May 4th through May 8th, I'm actually doing a presentation at a professional conference called Forest Sat. And it's all about people who are mapping out forest change. And I will be talking and highlighting all of the data that we have put together. And so if your students are participating, collecting data, contributing to the Globe Observer database, I am going to be mining that for all those contributions and giving acknowledgments during my presentation. We'll also be doing a workshop early in that week all about Globe Observer and NASA missions like what I've been showing you here. And so, yes, Tori, you nailed it. And so this is a great opportunity for your students to, not only feel like they're contributing to science, but to actually get recognized for their contributions. So I wanted to share that really wonderful opportunity that comes into some of these conversations that I can bring to your classroom. And so Joy, let's make sure that Tori can help coordinate us, and I will look forward to bringing what we just talked about today to your classroom, and getting some insights into what some of those students remember about their location as well. And Santa, I think, hearing from you and what you actually measured will be an interesting piece of that too. So Joy, I think, just to give you a reference, I think it's going to be 1986 or 1990. It'll be right there at the very beginning of the Landsat timeframe when this starts. But in Alaska, it's a little bit later than the rest of the world, and so I'll have to look to see. But this is one of those parts that's going to be different for everybody, and so I'll leave you with the final word: the first light. And that's the first imagery that you are providing for that location and that NASA recorded for this location. So we'll definitely go and find the first light images for your locations. And that's what I'm here for, is to help connect you with all of this. So as you can tell, I'm excited about this. So invite me into your classroom so that we can keep the conversation going.
Yes. Thank you.